if we're able to coordinate our efforts, collect this really large, beautiful data set that help us in decision making, but also make sure that the data collector is getting paid, then I think there's a strong increase in value that could be exponential.
Welcome to Learning Lab. This is Ma Earth's online community where we're sharing tools, skills, resources, and stories in service of planetary health and community-based nature restoration initiatives. I'm our facilitator, Sophia Rockland, and today we're joined by David Dow. David Dow is the awesome co-founder and chief scientist at an organization called GainForest. GainForest works with different nature stewards and land protectors around the world, from the Philippines to the Brazilian Amazon rainforest, exploring how different tools like Web3, AI, and satellites can practically create and translate data sets from different ecosystems, creating different economic opportunities and incentives for land protection. So we're going to dive into the world of bioacoustic data monitoring with David Dow today, and I'm super excited to have him join us and share a little bit more about the wonderful work at GainForest. David, I'll let you take it away.
Thank you so much for the really lovely introduction. So let me make sure that the slides and the sounds are shared. And as Sophia said correctly, today's presentation is about something that we at GainForest are super excited about, which is stories in sound, how bioacoustics, which is the study of sounds and soundscapes of the natural ecosystem, can provide not just insights, but in GainForest's case, also an income for ecosystem restoration. And this short presentation, like hopefully we have a lot of time afterwards in the Ask and Reflect section, really is meant to nerd snap you to learn more about sounds as a super efficient and low cost tool to monitor biodiversity, and also as something that is so fascinating because it gives us a really great door to monitor the animal kingdom and also the plants and forests with a very different but also very natural kind of way that's can only be experienced through listening. So I'm very excited about this. So this talk is called Stories in Sound, Earning Income for Ecosystem Restoration with Acoustic Data. And I want to just get started with a sound piece. So I'm playing a little sound and I just invite you to close your eyes, to take a moment to arrive. Let me see if that sound plays down. And to imagine nature as you listen to these sounds. And feel free to answer for yourself or in the chat what you see when you imagine nature listening to it and how you feel. So most likely it's earths, forests, mountains. In Switzerland, I'm based, it's most likely mountains. Some of you might imagine water. Some might you also feel and see people, which is also a really important part of nature. But all of us, when we listen to these sounds, and most likely you have experienced is this calmness, this tranquility. You're listening to the sounds. It creates something cultural in all human responses. And this is a really powerful demonstration of ecosystem services. We often talk about nature in terms of carbon storage, especially in the climate sector right now, where carbon credits are one strong financing wheel for nature conservation. But ecosystem service is so much more than just carbon storage. As you can see, there's this one carbon storage here, but it's really about clean air, purifying water, controlling flooding, fish, wood, pollination, these provisioning elements. Then you have the supporting elements like food, soil formation, biodiversity that we're going to talk a lot about. And the thing that you just experienced is the cultural element, the stewardship, aesthetics, recreation, and educational part that comes with nature, right? So really, nature at itself provides so much ecosystem services. But at the same time, we all know the value of nature. We see the destruction of nature itself. Data in satellites and also forest ground measurements have revealed a really shocking rate of destruction, which is we have lost half of the world's forests since industrial times. We can observe this in large scales. And so there's this kind of disconnect between we understand the value of nature from a human perspective, but then we also can measure the data of destruction from a satellite. And this is something that we at GainForest care a lot about. And we believe that sound is one of the ways we can learn more about nature in terms of trying to prevent the destruction of it. And I just want to give you another example how we can do this. So this one is, you will hear a sound of an animal, and I'm inviting you to guess what animal it is for yourself. So, like a little tip, this sound has been recorded in the Amazon rainforest, north of the Rio Negro. And you might hear this part of the sound. And when I first heard about this sound, I was scared to death because I thought this might be a wild animal. But then when I was walking with one of our indigenous scientists, Marina Mura, she was laughing at me being scared because she knows that this is the sound of a howler monkey, Naluta seniculus, which is just the sweetest small little monkey with a very big mouth that uses these sounds to communicate over a wide range of the forest, right? But you can hear that this and that story of me having a different kind of impression of what this animal is, but the local communities that I was like exploring the forest with and also collecting the data at that time were immediately able to identify just from the sound of the animal that this is like this little monkey, gave us kind of a very strong insight. First, local communities are amazing in understanding sounds and translating it to animals. Second, animals seem to have a very distinct feature that can be identified, which we all, of course, naturally know. So you can use sound potentially to identify biodiversity at scale. Even with me not seeing that little howler monkey, our group was able to identify that this howler monkey has been living in this forest, right? So another really cool thing about sound is because we can record sounds with sensors. Mathematically, we can display it according to what we call a frequency of the sound. So a frequency refers to the number of repetitions in a wave given a certain time span when sound itself is nothing but like an air wave, right? And the frequency is basically the kind of like how many times it's repeating. And the really interesting part about it is depending on my frequency of speaking right now, when I speak very low, this is a very low frequency. And so it's a low pitch. And when I speak very high, it's like a higher frequency, and the singers among us in the audience are very well aware of different frequencies and different pitches. And we humans, this is the really interesting part, can hear usually between 20 hertz to 20,000 hertz in frequencies. This is our human natural kind of like listening span. But when you listen, for example, to animals and their frequencies, how they communicate, this one is a really interesting one. So what you're going to hear is a very special rumble of an elephant. We all know elephant sounds with sound like a trumpet through the noise. But when they are very close to each other, they do a sound like this. Yeah, one more time, because this is very cool. So this rumble is something that you might not associate with an elephant. And that is simply because it's in the infrasonic spectrum. So it turns out that elephants have been communicating in a sound range, in the frequency range that we humans cannot perceive, but sensors can. And the same thing, of course, we know about bat noises, right? Like bats communicate in the ultrasonic part. Sometimes when you have really good ears, you can hear clicks from a bat, But that click is just really the limit of the high pitch of what they usually communicate in. They are communicating like and if you can, and modern sensors are able to record what we call a spectrogram, which is basically an image, a snapshot of all frequencies in full range, including those that we cannot hear. You can see here snapshots of the elephant on the left, snapshots of humans speaking in the middle, and snapshots of the bat noises on the right. And the intensity, the density of the color is the intensity of that frequency. And then the frequency itself is the range. And then what you see here on the bottom is just time. Right. When I speak something, then it draws like a really colorful image that goes, as you can see in the human speaking part, it's very variety. And that allows us actually very much to analyze these animals in a very specific way. Because it turns out that the trained biologist, and also later on we'll showcase that too, trained artificial intelligence is able to read these pictures in sounds. So these sounds pictures, these spectrograms, because every kind of animal, bird, mammal, insect, they have its own unique signature between species, but even so among individual animals as well. So, but between species, you have different kind of bird songs that have different kind of spectrogram visual inputs, as you can see here. And so you see that these different birds, they have all, when they sing, a very different kind of signature. And often trained biologists don't even have to listen to the sounds. They can read, and through their eyes, they can identify from the visual signature of the spectrogram what animal has been singing there. And that's very powerful. This is, for example, an example of an algorithm that is able to take a whole like spectrogram from 20 seconds of recording. This is 20 seconds of recording, and just analyze, looking at the frequencies, what kind of potential animals are there. Like you can identify, for example, a bullfinch, you can identify cricket in the middle, and you can identify frogs, because you know they are all kind of living in different frequencies with different kind of signatures. And so just by not finding them, so it's the beautiful part about this is, first of all, you don't have to kind of capture these animals to measure that they are there. So it's very, it doesn't harm any animals. You don't even need to see them. You can hear them. And hearing is oftentimes a very strong and powerful sensor because it's a passive measurement compared to, for example, a wildlife trap that only looks at one direction, or the fact that you have to wait in the bushes and capture a frog, which might shock the frog, right? So here you can observe animals in a very natural environment and kind of collect data in a large scale. And also, even though it's not about animals, sound itself can be a really, really important factor in telling us how healthy an ecosystem is. This one is also a forest. It's actually recorded very close to the first call that with the nature sounds that I played in the beginning of the presentation. And this forest is next door. And you can just listen to it for a second and guess what kind of forest this is. So this is also a forest. And listen and hear how you can only hear the rain and like some, we call it geophony, but you don't hear birds anymore. You don't hear biodiversity. You kind of, it doesn't give you that tranquility. It's actually, it's a little creepy. And that is because this forest is a eucalyptus monoculture. It's very close to the first forest, but it was planted solely for the purpose of timber harvesting and carbon credits. And eucalyptus has this really, this biological property that it's one of the fastest growing plants in the world. It grows really, really fast in 10 years to its full size. But the leaves of the eucalyptus, when it falls on the ground, is very toxic. So it's only very few animals can actually survive in an eucalyptus monoculture. And this kind of introduces that kind of like scary feel of a lack of biophony. So I want to introduce you to the concept of biophony, geophony, and anthropophony. which are three classes of sounds. So you can imagine you see the spectrogram, which is time over frequencies, which is a wonderful tool how humans and AI can identify potentially animals inside. But even if you don't know, for example, the signature of an animal, because we'll talk about it in a second, many animals, we just simply don't know their signature. We can understand from the type of the sound if it's a man-made sound, an anthropophony, if it's a biological created sound like the biophony, or if it sounds from rain, from thunderstorms, from wind, which is geophony, right? And there's this really interesting way to measure anthropophony, because anthropophony is very simple in its nature. Nature is very complex. A bird sound changes frequencies very, very fast. So in very short term, you have a really beautiful sound, right? While a machine, you can imagine like when you just imagine a construction site, or maybe like your router connecting to the internet, or your phone ringing. It's like beep. It's one frequency for long term without any complexity. And that's how we can actually use frequency analysis to re-identify this is human generated sound, this is geological sound, and this is biophony, right? And it gives you a measure of human disturbance. Because in a city, you will measure a lot of these anthropophony sounds, while further outside the city, you will see a correlation of more complex sounds. And that gives you a really strong, and I'll show you in a second, strong indicator of healthiness of your forest. So, but where does the payment come in, right? Why would anyone be interested in collecting that data and pay for it? And that comes really much to that one. So my background is I'm an AI researcher. So I look at large data sets for a long time. And one of my passions was to integrate AI with nature data and with natural detections and analysis. And I was looking at just what data was out there. And we looked at the world's largest database, which is the Global Biodiversity Information Facility, which has collected all the world's data observation of animals, of plants, of whatever has been measured is in this database. And I want you to kind of like answer for yourself how much of the world's biodiversity data was measured in Europe, North America compared to the rest of the world, right? This large database with, I can tell you, almost 3 billion entries. How much of that is Europe and North America? And the answer, I was not prepared for that, was quite shocking. 82.43% as of last, like I measured it in March this year, is from just those two regions of the world, leaving 17.57% of all the data points in the rest of the world. And even worse, like the most biodiverse parts of the world, the Amazon rainforest, Southeast Asia, Indonesia's forest, and Africa's rainforest is the second largest rainforest in the world, the Congo rainforest, like, for example, has only 0.01% of biodiversity data that has been measured by science that belongs to this area. So if you plot the world, how it looks like, according to resizing, according to how much data there is on nature, you will see that this is not the map of global biodiversity. This is the map of global GDP, which is a big problem in so many ways. One problem that causes is, of course, as we are in the midst of a technological revolution where AI is feeling like taking over everything, artificial intelligence algorithms are only as good as the data they are provided with. And so you will create a very dangerous bias in decision-making when you use these algorithms. Here are two examples of computer vision back in the early days when we had a problem with data sets that were already biased towards a certain kind of majority. And you can see here, for example, one of the early image generation models had Barack Obama in a fuzzy version, and data bias created like someone that does not look like Barack Obama. Or on the top right, you have Joy from back then as a PhD student at the MIT Media Lab. And she identified and measured face recognition algorithms and unfortunately detected that they didn't detect her face back in 2018 and 19, but only when she put in this white mask, it was able to detect face. So data is biased. and algorithms can amplify existing systematic biases. And that's why it's so important to collect more data. And that's what we at GainForest are doing. We're working with 35 local community members and partners around the world right now to deploy sensors around the world, and especially bioacoustics, because we believe that this is a very strong sensor that has so many really great opportunities for communities to engage with in citizen science perspective and educational properties. And so we are using that to basically reward people for collecting data. And how our system works is the following. From those 35 communities, we basically assume most of the communities have never collected any data or don't have any data infrastructure. That's also one of the reasons why there's this data bias for the global north. And so we pay them currently 1 cent per minute of bioacoustic. In a second, I will tell you how we come up with this number, just for recording that data. Use a sensor called an audiomorph, later also more. And you just get a couple of cents per recording that you're recording in your forest. And that usually can generate a small income that's able to finance, pre-finance, post-finance these sensors, but also allow you, and some of the communities bought an Starlink afterwards, to better be connected to the internet. And then from those projects, 10 of the projects reach something we call level 1, which is now you have a decent local data collection infrastructure and you collect more and more data, and still you're receiving conservation data income, CDI, which is our level 0 funding. But now you also display so much of your data in a platform that we call the Green Globe, that is a visualization platform of all your data for your project, that you can reach out to philanthropy yourself and show them the very impactful work that you're doing, because data is not lying, right? And so 10 of our projects that we have worked with over the years are now able to raise funds without GainForest. In many ways, they're raising funds that are able to sustain themselves for a whole year or more, and using the data tools that they have started learning with us in level 0. And 2 projects, this is the next step of data-based income, are able to get contracts from industry and academia because they have trained and built so much capacity internally that they are, first of all, experts in birds. They are able to identify, for example, ecosystem health. And then academia and industry is very interested in, for example, calibrating machine learning algorithms for carbon prediction and biodiversity prediction. But also industry is really interested in like biodiversity credits or assessments or help with that. And so 2 of our projects were able to get funding through just collecting more and more data. And we believe actually that in the end, none of the projects so far have reached level 3 of our pipeline, but this is where we believe that your data point that you collected and wrapped around methodologies and standards becomes so valuable that it can be served as a potential ecosystem biodiversity credit that can be hopefully compliant to the market itself. So that is the dream that we're pushing forward to, but it's so exciting to already see some projects like going up this level, leveling up their income through data. Conservation data income is the idea that we got funds from at GainForest that we raised through, of course, donations and prizes that we won. And a large chunk of this fund, this treasury, is governed by the committee's members themselves. And we have a data council, we call it, that is elected through every 6 months. There's a vote that is electing a representative of the data council of Southeast Asia, South America, or East Africa, and they sit together and determine the data policy. One of the big problems that we always wear is how much we pay for data. And so it's much easier to just be very transparent. This is how much cash we have. This is how much data I think should be needed. And then you let the communities decide, regularly revisit and self-govern that treasury so they support each other. And that turned out to be our solution of setting the price, currently at 1 cent per minute of bioacoustic, which I think is quite a very decent amount, and 5 cents per megabyte of drone imagery. And also there's a quote per request for 3 images. And then we have an internal blockchain-based infrastructure that allow you to receive these funds on your phone. We're working with several partners that use stablecoins and Celo to reward these. And this is, for example, one of our data partners in the Amazon rainforest that has just received some of the funds on his app. And then Gabriel, was able to go to a local actually fishing market in the Amazon that also accepted this cryptocurrency because it's quite adopted. So it's a great way to support banking the unbanked, and also just make sure that these micropayments are efficient and don't take you too much of an overhead. So, because this presentation is stories and sounds, I want to end this presentation with some stories that I'm really excited about. So we're using these audio muffs. I have one here. I can show you later. They cost $90 per piece. It's still very expensive for local communities, but it is open source, and we are actually cutting the cost right now by trying to manufacture them in more cost-efficient ways. But right now, when you would buy them, not from us, but from the global market, will be $90. They require 3 AA batteries, and they have a recording range up to 384,000, 384 kilohertz, which is basically enough to listen to anything, bats, insects, frogs. And what we do is we visit the communities. You can deploy them either in a case like this, like a ring cover case, or a very cheap and hacky solution that works perfectly well is put them in like a phone dry bag, like here Fatin is doing during her work in the southern Philippines. And then they are deployed there, and we use a small, simple app called the Arbimon app to manage and store the bioacoustic data. And then they're hanging there, recording 24/7 for 3 weeks. That's how long the batteries will last. And for example, one of the things that we can measure is this really, really cool index. I told you about biophony, anthropophony, and geophony, and that the complexity of sounds is basically telling us a lot about the health of the ecosystem. What you see here is an average index over 3 different kind of ecosystems: a healthy mangrove forest, a restored mangrove fish, like a fish pond with mangroves, and abandoned fish pond in blue. And you can see the higher the number goes to 1, the more complex the sound is. And the lower it is for 1, the less complex it is. Less complex means less life. Usually it's a proxy. There are scientific studies that correlate these two together, but take it with a hint of salt. And you can see, though, the difference between the blue line and the green line, and the increase of the brown line. Because the brown line used to be a blue line until the mangroves got restored. And now it's increased in acoustic complexity, which is a really, really good sign for the health of the forest. This one is one I really like in the Amazon rainforest in Santa Helena do Ingles. And here, this is Marina on the left, the indigenous scientist in our team that has saved me from the howler monkey, from being scared. And on the right is Gabriel, the person who just received the funds in the previous slide, hanging one of the bioacoustic sensors and earning some conservation data income. And this is, for example, a really cool analysis of max frequency. So what you see is which kind of frequency spectrum has the strongest intensity at this time, right? And red frequencies are usually associated with birds and with mammals, and then greenish one are insects, and bluish ones is ultrasonic. This is bats, right? So what you can hear is kind of what you can see in the left side is a very healthy ecosystem. It's the forest, and you can see the peaks at 6 a.m. and at 6 p.m., which is the dawn and the sunrise. And you can see this kind of really significant peak of bird activity and animal activity at these periods, which stands for a very healthy forest. Also, the color shift shows a very healthy, strong transition from insect-heavy to bat-heavy areas. While on the right side, you see this is a indigenous urban territory where the colors are less distinct. You don't have a less transition, right? And that is a heavy ultrasonic to insect-based ecosystem, and that is what sound can give you. And here, an analysis for all 3 different parts in Bay, which is a very indigenous territory, Ingles, which is more inside Riverside Community in Parques dos Tribos, which is a urban neighborhood, and you can see the different kind of signatures of the spectrogram. And yeah, so without further ado, I think maybe I'll leave one more slide on how we actually pay out. So what we do is all conservation-based income, you basically issue something called a hypercert or EcoCert, which is our kind of data point, but wrapped in. So an EcoCert is impact certificate that you can issue without having any data in the beginning, right? So very different from a carbon credit where you need to do a lot of upfront work to even issue the certificate, up to $500,000. An EcoCert is super simple. Everyone can just issue and claim, this is the impact I've done. But then the beauty of it is it's more like a liquid finance solution, because at the beginning, of course, it's valued at zero. No one will purchase that. There's no demand for it. But as you wrap it with more sounds, more images, more data, you can link this EcoCert with more of that. The more valuable it gets, and then actually it helps you in fundraising and selling these impact certificates as you collect more data. And this is the way we do this level 0, level 1, level 2 fundraising through these EcoCerts. And so we will also be able to talk a little bit more about this in a later session. So I hope I was able to nerd snap you for sound. I love sound. I think it's one of the greatest storytellers in the world, especially when it comes to nature. And it's very healing as well. And at the same time, it's so scientific and so exciting, because it's the frontier of human and AI analysis of nature. And so I'm super happy. If you guys want to reach out, you can always reach out to the team at GainForest.net for more questions. But for now, I would like to stay at this slide and just take any questions and reflect.
Yay! Thank you so much, David. I am so excited. I was looking at those slides beforehand and just feeling very excited to hear what you were going to sing about. It's funny. There's a mockingbird outside of my window right now. We have a mockingbird, and it repeats, I guess, anthrophonic sounds or human sounds. So it makes car alarms, and I was just wondering what kind of challenges the mockingbird might present. We have some great questions in the chat box. I'm going to take moderator's privilege and kick us off with the first one. I'm sure that a lot of us watch this and think like, this is very cool. How can I get involved? And something that I really love about what I've been seeing with GainForest is understanding how you guys are actually bringing in different groups from around the world who are different land regenerators, people, everyone from livestock herders in Eastern Africa to people in the Amazon basin. And you're actually working with a very diverse group of people, introducing them to new funding streams. And so, when we talk about nature, like basically income for conservation, I'd love to know right now, where are those funds coming from? And number two, how could, folks in this webinar and, watching beyond actually begin to get involved with these kinds of funding rounds? Or what is this landscape of funding that you're talking about? Can you introduce us to that a little bit more?
Totally. I think this is such a game changer for us as a conservation community to understand that there are funds that are not just institutional and that are a little bit more free. So maybe to recap on this, so we have different kind of funding streams depending on the level of the communities they are in their data funding journey. So the level 0, level 1, level 2, level 3, that slide that I initially showed, these fundings are coming from different kind of partners. In level 0, it comes from us. So we're paying the 1 cent per minute, we are paying the 5 cent per megabyte. And how do we get these funds? We have fundraised it in the past, but then very recently we have won a bigger prize, the X Prize Rainforest, where we used the prize money to create an endowment fund. And that endowment fund's interest rate is able to pay for these small sums right now. So that is where level 0 funding comes from. Level 1 funding, and that's much more interesting because there is funding in the $5,000, $10,000. There's one project that we are very close with that just raised last month $25,000 from level 1 funding. Great project in Uganda with honey and bees. And that how this is done is through a similar idea of an endowment fund, but in Web3. Web3 has a community that is called the public goods or funding the commons community that cares a lot about funding impactful work. And in the Web3 space, funding comes from different kind of ways that is a little bit more faster than from an institutional perspective, where in the institutional perspective, you need to kind of apply for grants. And you write a grant proposal and you submit it, and there are reviewers of grants. In the Web3 space, you have a smaller sum of it, like $100,000, $500,000 that is distributed to way more people. Up to 50 to 90 projects get some funding, like small to larger. And how it's distributed is through a mix between machine learning algorithms and data analysis and human judges that look at your projects, look at how much they like, and then you can get something like a matching donation as a vote of confidence that you like this project a lot. MyEarth has run a really wonderful round using this mechanism, and then a larger amount of funding is getting matched depending on kind of the most popular or the most trusted projects through this kind of matching voting process. This is level 1 funding in the Web3 space, and you can raise funds up to, I would say, $100,000 in total through just this pipeline. And that pipeline rewards you, especially when you have a lot of data. And that's where the importance of data comes from. Because we have onboarded more than 10 of our projects in this level 1 funding, and they have raised in total more than $100,000 together. And we can see that it correlates depending on how much and how well of a data and storyteller you are compared to how less you are, right? So this is level 1 funding. In level 2 funding, much larger fund. We're talking here about up to $300,000 is coming from contracts from, for example, we had 2 contracts in the past, one with MIT Media Lab and one contract that one of our partners got with the Korean government. And that is traditional institutional grants again, but with a very powerful storytelling of showing the data, and then that data actually is an incentive for the grants. So for example, both of these larger institutional grants that level 2 funding has as goal to collect more data for scientific reasons and for reasons of accountability on the government level, for example. So these are kind of the venues of funds that we explored. We have also seen all these other funds that probably you in conservation space will know of, like corporate sustainability. We have received funds. We have received donations, of course, of family foundations as a nonprofit as well. And in all of these cases, data and storytelling and science is always a strong convincing argument why people should give you money, for sure. And that is kind of what we summarize under a data-driven funding pipeline. And how we can get involved, maybe to answer this question as well. So we're super open to grow organically. We usually expand our network through recommendations from existing communities. For us, the most important part of this community is trust, because the funds are governed through the data council. The communities themselves decide who should be onboarded next, right? So, but if you want to be onboarded and you want to learn more, please reach out to us. We have several community managers that are just there to support that onboarding process. And we have strong monthly community calls where you can also meet everyone else. And that's how you can get involved.
Awesome. And I'll be sure to share that information with everybody after this session. I can attest to the quality of GainForest's community tending. I join those community calls every month, so I'm a big fan. Okay, we have quite a lot of questions. So I'm going to attempt to braid 2 questions together. This is a combination of Escott and Charlotte's questions. So Escott asks, beyond species identification, what other information can your spectrograph analysis reveal about an ecosystem's health or changes? For example, population density, breeding patterns, or stress levels. And Charlotte also asks specifically about water health, or if that's possible as well. So yeah, I can read that again if you want.
No, I think I got it. Also, Charlotte's good friend, so I know that she loves water, which is amazing to have you here. So Sound is at the frontier of science, meaning that there's a lot that we know sound serves a really good proxy. Some we believe it serves as a really good proxy, and then there's a lot of things that we don't know, but we believe there might be a way to identify it based on advancements in machine learning. But for what we know, is it's a great species identification tool. When you have the labeled birds and the labeled frogs, it's amazing. It's probably one of the world's best. It's a great way to measure human disturbance. So there are nonprofits that, such as I call Rainforest Connection, for example, that uses some of these sound sensors as an early warning system for human logging, because chainsaws obviously are very easy to detect, and so are planes with illegal landing strips in the Amazon. So that is a very strong indicator. You can measure the richness of biodiversity, I believe, in a certain degree. So that is still discussed heavily, but the complexity of the biophony sounds are a very strong indicator of the complexity of life itself. So you can imagine quick visual proof. So in fact, this spectrogram, you can imagine that to be a big single bar. Like, you're trying to communicate very loudly to attract your mate to come in, right? So many species want to kind of like communicate at the same time, because there's only 24 hours in the day, so you can communicate and find your partner. But you don't want to overlap, obviously, with other species, because then it's really hard for your partner to hear you. So what happens is these animals develop this, and this whole theory is called acoustic niche hypothesis, which is beautiful. All these animals develop their own radio channel frequency, so to not overlap to each other. And so when you take a picture and all these frequencies are covered with complex like sounds, you can imagine there's a lot of animals out there, because there's like basically they pack out all the whole. You're like in an area with a lot of radio channels, right? With a lot of radio stations. But if you're in an area where you only hear a few frequencies covered, that's an indicator for a low biodiversity, because there's so much space for animals to kind of communicate and mate, but they're not using it, meaning simply that either there's a very difficulty for them to express themselves for sound, or they're just not there, right? So the density of your spectrogram, I believe, is a strong proxy of how complex your biodiversity is. And then there's, of course, you can hear that in the monoculture, that has very low biodiversity measurable. You can hear barely no sounds. You can use sounds to identify different kind of types of forests: primary forests, pastures, plantations, restored forests. So you can use it to classify. And then regarding water, so what you can hear is definitely you can measure the water cycle. So you can hear storms, tropical storms, you can hear rain, you can classify rain really well. If it's close to the river, you can measure the intensity of a river, but that river will take over and cover over a lot of other sounds. So you probably will be only able to measure the river's sounds, right? But that river sound will give you a lot of insights of, for example, what's currently the state of the river. Yeah.
Amazing. Yeah, I love this universe. I think there's no reason why sound shouldn't be really at the forefront of our digital imaginations and priorities. We have, a couple more questions. There's a question from Marco. Marco says, "Hi, I'm an audio signal processing engineer. This is very interesting and a great use of machine learning. Can people cooperate on the algorithms?" And then there's another part of that question. Also, do you have any pre-processing on the edge, or do you just post-process offline? How do you ensure that signal quality is sufficient and that recording doesn't have to be discarded?
Such a good question. So first question, how can you collaborate? 100% yes. So much of the tools that I showed you today is not from us. This is developed by almost 15 to 20 years of bioacoustic research. So just Google acoustic indices, and there has been 50 indices that has been developed by scientific literature. The ones that are the most commonly used right now is acoustic complexity, acoustic evenness, acoustic entropy, and bioacoustic indices that you can use and you can develop. Indices are really, really fast way to process sound. We ourselves, if you go to GainForest, on Hugging Face, or maybe we can share the link later. We have an open source repository of machine learning algorithms. One is a bird classifier that we trained using a larger database called Sino-Canto. But I wish there would be more people interested in that. So that code is open source, and feel free to just play around with the model. Otherwise, there are better models than ours. Cornell University has a really strong model that is open source called BirdNet. And then I know of other companies that are working on proprietary model, but I'm sure if you look in GitHub, there's a lot of cool classification models out there. Because one of the problems is not really the model, it's really much the data. There's a lot of lacking of labels of these signatures. So that would be also a strong way to collaborate in. And then the other question was on edge compute. It's something we've been thinking about. So right now, one of the things about these sensors is you cannot use your phone to record it. And Marco has correctly said it. It's because when you record it with a phone, there's a certain kind of type file that is needed. You cannot compress the media file. You cannot use MP3, for example. It should be a WAV file, because when you compress the frequencies, you will distort it from the actual way the animal is like singing, right? So uncompressing, it's really important to save uncompressed sound files. And the way we do computing is right now we do post-processing. We install these sensors, these algorithms, they're here, and they have an SD card inside that stores all the data in its raw format. And then every 3 weeks, local community members take over that SD card and upload the data into the cloud, where we do most of the post-processing. But I know of friends, and we're also exploring ourselves with new chip design, of if we can maybe create a small PCB chip that basically also includes the edge compute in it, because then you can think of things like on-compute acoustic indices computation, and you can send that signal through long-range Wi-Fi through LoRa without needing to kind of like store all the raw data. So that's an idea we are exploring right now, but it's still early stage.
Right on. Okay, couple more. Ready, David?
Yeah, of course.
We have one from our friend Gmo of Sylvie. And I'm going to see if I can English this one here for myself. This is not my domain per se. Gmo asks, how about dynamic data bounties to drive for data where there are data gaps in southern and tropical forests, for example? And he also asks, how are you determining the value of a drone MB in terms of area per pixel, etc.?
Yeah, such a great question. So one of the things that we realized is in the everywhere where we've been so far, in the global south, global majority, every time when you collect data there, you're the first one. So I absolutely agree with the dynamic capture of data, but because we are so remote, for now it's easier also for the data council to fix the price, because usually you will not have data in that area, except of course if the community has collected that data previously in that area. So that's already happening to a certain degree, because sometimes you just record it the whole time in Manaus, and then you have the same one again. So there is a potential idea to introduce dynamic data bounties depending on how far and how different they sound from previously existing records. But right now we're definitely exploring it, but we want to keep it simple for now to make it easier for people to understand. And so a fixed price is usually a bit easier to get started. And then dynamic data bounty is definitely something I would also love to jam if you have time. I think this is a really great idea. And then regarding the drone images, it's a similar idea of, yes, it would be great to have it dynamic, but right now it's more of a request of an area. For example, in the areas where we work with, for example, in the Philippines, where we have most of the drone images, they are usually captured in areas where they have in their previous tree measurements, because that's where the value of the data comes in. So these drone images are usually there where the conservation sites are. They come in with a certain kind of purpose already, and then these 5 cents per megabyte are just on top of it as a sweet spot. We have We don't receive drone images from community members that record areas that they usually are not active in so far. And that is simply because the 5 cents are probably not that strong of an incentive for them to do that. So they usually just capture their own areas and send it over. And that's how we currently just determine the price. And the price might change also depending on how people are gamifying it or not. For example, the tree images, that unfortunately we were not able to solve. So in the past, we paid 30 cents per tree image. But then we saw that the quality of the submitted tree images are a little bit difficult to assess. And there's also a way, I know that Sylvie has a really great app of doing this. But for us, for example, one of the problems was that you take the same image of the same tree in different angles or at different times. And then the 30 cents per tree image doesn't work anymore. Because, and it's not even the fault of the community. It might be a human error because so many small seedlings, right? And so that's why the data council decided on this perspective to stop the payment and do it only at request. But I think it's a mix between system, kind of like checking, and social checking. Yeah, social governance.
David, that slide that you brought up with the gross overcategorization of European and North American, or I think it was just European data sets versus global majority data sets, was pretty. It was. I'm sad how not shocking it was, but it's still a shocker. And Ken asks a question that's related to that. They say, how does the sound data compare to the data that is currently in the database dominated by North America and Europe? And can you deduce similar variables?
So the map I showed is actually North America and Europe. So the 82% is from both regions. And the sound is a subpart of that data set. From the almost 3 billion observations, sound is a tiny fraction. You can actually look at it either in the Global Biodiversity Information Facility, GBIF, or sound has its own kind of database called Shinokanto that you can observe. And usually it's really sad. Like it's big, but it's an emerging sensor. There's basically almost no observation of sound in the world. It's most of the sounds are in North America and Europe. And that's why when you, for example, you might have tried it out. There's these bird detection apps that you can record a bird sound and it will tell you what bird it is. It will work perfectly in the US and it will work really well in Europe. But I think, like, also talking to communities and very strongly from my own experience, it will fail to work in the Amazon or in East Africa because simply the biodiversity is so rich and many of these birds have been understudied, right? And none of these signatures are available. So really sound, I haven't done the full analysis yet on Shinokanto, but I think it would even be even more uneven than the statistic I showed you. My feeling is actually that probably 90% of all sound data is from North America and Europe. Yeah.
Okay, we have a couple more questions, but I'm going to I think we have time for one more. So Josh asks, all right, ready for this one? How do you envision the value and flows of nature data scaling in the next 5 years?
I think if we as a human society achieve, and we've done this already with satellites, and that has been immensely helpful, achieve global coverage of monitoring, we can push decision makers towards accountability. Satellites have been used now to measure deforestation globally, right? And in certain degrees not, it helps to kind of raise awareness to stop deforestation. So I hope that we have something of a global coverage with sound data, with on the ground data, with community crowdsourced data, like a sensory network of human citizen science participation. And as the value and as this amount of data grows, the value of the data grows. This is one of the beautiful characteristics of data is data is combinatorial. So as you have more and more data points together, the whole data set itself will increase in value. And then you have people like, and we've seen that Google, Facebook, they've all taken iNaturalist data which they granted for free, or a global biodiversity information facility there to train like large nature models right now. Unfortunately, not with paying people back. And I think one of the things that we need to shift as a community is understanding that this data is not free. It shouldn't be free. It should never be free. It should be always with a certain kind of commitment paying back to the data collectors, because that's really, really hard work. And if we're able to coordinate our efforts, collect this really large, beautiful data set that help us in decision making, but also make sure that the data collectors getting paid, then I think there's a strong increase in value that could be exponential, because again, data is combinatorial. And so the larger the data set, the more valuable it becomes.
Thank you so much, David. And thank you to your team at GainForest. Honorable mention to the elephants and the howler monkeys and all of the other creatures that we collaborate with to make this work possible. If you would like to learn more about GainForest's work, get involved, stay updated, you can find links in today's show notes. You can also sign up for Ma Earth's newsletter, where we share different tools, resources, and occasional event updates. Thank you so much for joining us, and we will see you next time in the Learning Lab.